me from the super highway and come to here. Take about 40 minutes because we are the first time to come Zhonghua University, and I wish you have a very successful annual conference. Today is the last day, right? Yesterday you have opening ceremony. Okay, let's go back to the speech. Okay, the content of the research, including the introduction, also methodologies, results and discussion and conclusion. Okay, introduction, location, issue, and watershed management. Taiwan, is here, okay, and most of your country, Indonesia, is in the lower part, okay. And the site of the research, my research is in the central Taiwan. You know this is a famous lake we call Sanmu Lake. Sanmu Lake in Yici in Nantou County. So my research site is just beside the lake. It's about 60 hectares. Okay, the area. The watershed information is belong to the Suili and the Yici village. Okay, sorry. Its total area is 61.5 kilometers square. Demography is a decrease in total population trend. due to the immigrant. You know, this is a phenomena of the Taiwan rural area. Most of the young people move to the urban area. Economy, agriculture, and tourism. Religions, 90% belong to the Dao. Daojiao is one cultural religions in Taiwan. Temperature is about 16 to 26. It's another very high variation. The temperature is good over there. Evaluation, half area, this area is the slope is greater than 53%, and elevation is between 300 and 103. 1,390 meters. Precipitation is about average in Taiwan, 2,200 millimeter. And most of the raining is very in May, June, July, and August. It's about the typhoon season, summer season. This is some background. And the picture of the agroforestry in this area is about this kind of type. You see, you know this tree name? Betel palm, betel nuts. I don't know your culture in Indonesia, but in Taiwan, many people eat that and like a breed, right? It's a tree we call a betel palm tree, and also you can see the paddy field in this area. Some banana tree, and this is also betel nuts. Okay. What are the issues for the watershed management? Is coming from soil erosion, and soil erosion causes the water quality problem. Also, because the people relies on the agricultural production, so the agricultural productions need enough income for the farmers from the land. So that is mixed issues from the conservation, also from the economic side. So we need to solve the two kind of, we look at different kind of problem together simultaneously. Okay, I use GIS. You know the technique. Okay, this is expertise in this field. I use the cell to calculate the land uses right now in that area. Okay, each cell is 900 plus 900 meter. So it's each cell. And I count the cell number. I found forest, most of the forest is in the slope over 45%. Okay, this is a distribution of the forest. The right now land uses pattern. Also, this is a pastures. And tea is most of the tea plant in the slope 30 to 45. The tea is not plant in the lowlands because not enough moistures. Okay, but cannot go too high because too cold. The tea is not grows well in that situation. So about 30 to 45. And betel palm, you can see the red one is almost occupied different slope of this watershed, from the slope under 5% to store between 45 to 100%. So you can, if you go there, you can see the beetle palm everywhere, from very flat land to very steep land. Okay, it's also the problem of soil and water conservation. Okay, cause a lot of soil erosion. And you can see paddy field. Paddy field we know is most of in the flat land. Okay, and this is a residential, and the last one is an open space. Okay, so the cell number is in the y-axis is from 0 to 25 cell, and this is the slope, the land slope. I use the GIS to calculate the number of cells. Okay, this is another pictures. I use the image to show different kind of land uses pattern in this watershed. This is the whole watershed. Okay, the shed like this. And so I hope you can read Chinese. If you can read, you can know different kind of land uses pattern and in the space location. Okay, it's very powerful in GIS technology. And what is the cost to prevent the soil and water erosion? The practice is including forest management, stream regulation, farmland erosion control, farm road erosion control, landslide control, buffer strip for readable, because they are too readable over there, and others. Methodologies. What kind of methodology I use to solve the problem? I use on-site erosion control cost function, objective function, and constraint. Okay, erosion control cost. I use regression to regrade cropping factor C, and the cost of the engineering prevention cost. So you can see C means the highest value of 1 means uncovered, and the highest the number means you need spend more money to prevent the soil erosion. So this is a very simple regression. You from use the cropping factor C and to estimate the total cost of the erosion control. Okay, so you can use the regression function to make this curve. If C value is high, the erosion control cost goes very steep, very fast. So the regression function makes the graph. Oh, okay. The second part of my model is the objective function. Objective function is coming from, I don't know, you use this. Okay, next some. Wait. Hello, 1, 2, 3. Okay.
Just give it.
Okay. Not okay.
Okay, no.
Makes my land use economic return. I use 5 graphs to estimate what's the benefit from the agricultural productions. And also I need a subtract the cost functions. So I maximize the agricultural productions and subtract the cost I spend in this slopland. Okay, this is my objective functions. And 5 crops including timber, betel palm, tea, papaya, and sweet potato. I think you have all the 5 crops in your country, right? Okay. Then next. And also constraint is coming. Each cell you have the tolerance soil production. Each cell I mentioned is 900 plus 900 meters. Each cell you have the optimum soil erosion, and you calculate each cell soil by using the formula, okay, erosion formula. Then it must be less than this tolerance, the number, the up number value. Then this is our constraint. Okay, next. Also some constraint from the each one. And this means a crop, 5 crop. This means I have 75 cell, GIS cell in this watershed. Okay, next. Result and discussion. I use this model to recalculate what is the optimal allocation for the agricultural crops. The result is a forest 13 cell, betel palms 8 cell, papaya 54, and another 2 is not recommended. So you can compare the model calculation and the reality is right now a location. It's a different. Okay, it's a different. Okay, next. So the last one is not recommended for this model, and also you can produce the results to know what kind of crop in this map in the space distribution. So you can see forests, most of the forests in the higher steep land, and betel palm and fruit in different area. Most of the fruits plant suggest plant in this area. Okay, next. The model choose forest is for the slope over 37.5%. If the C value, remember, cropping factor, has been decided, the optimal land users would choose the highest agricultural benefit crops. It's a mechanism for you set the objective function and constraint. The on-site erosion control is trivial. It's means not very high cost compared to the agricultural benefit. So in other words, agricultural benefit is more important compared to the erosion control. However, we will discuss later the erosion control cost next. The total erosion control cost excluded off-site erosion control cost means that the cost functions, I get the information only on the watershed, inside the watershed. But we know that if you do management, the other costs may be occur in off-site, not in your watershed. It could be downstream. Okay, so those costs is not into our model. economic benefit of agricultural production and products in terms of price are fluctuated. Okay, it's also the weakness of the model because I give the benefit means I give the price of the agricultural product, but in reality, our agricultural product price is fluctuate. This year is not even different from last year, or this month is different from last month. Also, so it's a problem. Okay, for demonstrate purpose, only 5 main crops in this area are chosen. I choose most of the farmers planted in this area, but it not means only these 5 crops is for model purpose. So it's about the last one, right? Okay.